Consider the free body diagram for example 2, where F sub n is the normal force on the sled. The sled weight is W, the friction force is little f, and the tension force for connecting the sled to the tractor is F sub t. We're given the values for the weight, the tension force, and the friction force, and we're told that we're moving horizontally 20 meters. And note that because we have the situation where the normal force is perpendicular to S and the weight is perpendicular to S, they do no work. That's because the angle between them, between Fn and S, is 90 degrees, so the cosine of 90 is 0, and we don't get any work from those. In fact, anytime the displacement is perpendicular to the force, there's no work done by that force. So if we look at the work done by the tension, that's going to be the force for the tension times the displacement times the cosine of the angle between them. In this case, it's 36.9 degrees. So if we plug these values in, we get 5,000 newtons times 20 meters times the cosine of 36.9 degrees. That gives us about 8.0 times 10 to the 4th joules, which is also the same as 80 kilojoules. And if we look at the force of friction, the work done by the force of friction would be the magnitude of the force of friction times the displacement times the cosine of the angle between them. So we're told that the force of friction is 3,500 newtons. The displacement is still 20 meters, and because the movement, say, is to the right and the force of friction would be to the left, this would be an angle of 180, and this gives us about 7.0 times 10 to the 4th joules, which is the same as 70 kilojoules. So the negatives. So the work total is going to be the sum of all the works. This is work for the normal force plus work for the weight plus the work for the tension plus the work for the friction force, which is 0 joules plus 0 joules plus 80 kilojoules plus a negative 70 kilojoule, which equals 10 kilojoules. And so we can do it this way. We can also try and do it another way. And the other way uses the sum of the forces methods. So let's consider the sum of the forces in the x direction. That's going to be the tension force times the cosine of the angle theta between the tension force and the horizontal in the x direction, plus a negative friction force, and that equals 5,000 newtons times the cosine of And then if we do the same thing as the sum of the forces in the y direction, we're going to get the tension force times sine of theta plus the normal force minus the weight. Which is again not going to contribute any value. So no matter what this is, this will do no work because it's perpendicular to the motion. Also, we don't know what the normal force is, but we can find it. So the work total is going to be due to the f of x component dotted with or multiplied by s, and these are in the same direction. So we get 500 newtons times 20 meters, which is 10,000 joules or 10 kilojoules, which is exactly the same as the answer we got before.